Good afternoon, students of Renton St. Mary's. Today's lecture is going to be on the oxidation and reduction type of reactions. And for the most part, these are fairly simple as far as concepts are concerned. Obviously, they can get complicated when you start accessing lots of different chemical reactions and trying to type them as either oxidation or reduction. And so we'll try to keep it basic here, just trying to understand just a few things about oxidation and reduction reactions. Okay, so an overview here. There's lots of different reactions that are oxidation and reduction, but the idea is you can't just have an oxidation reaction or you can't just have a reduction reaction. They always occur together. And for the most part, that includes, the extracting of metal from an ore, and we'll talk about that specific part right here. It includes extracting metal from an ore a little bit deeper. But for the most part, we're talking about the idea of oxidation occurring and reduction occurring together. That's the basic premise. Okay. Now, salt on the roads. This is not referring to salt's ability to melt ice. That's something that we would have to discuss later. This is simply about salt getting on cars, getting on wheels, getting on anything that is iron, and it since salt really dissociates in a solution and becomes an ionic solution, you can carry electrons a lot easier. So therefore, it's easier for oxygen to begin to rust that metal. So the ability of salt to dissolve in water and dissociate into a metal and a non-metal allows it to carry electrons a lot easier, just like an electric current. And that also allows, especially with oxidation and reduction, allows for the breakdown of metal into a different compound. Okay, so what's some common things? We won't spend a lot of time here on oxygen's characteristics here for the most part, but it is the most abundant element on Earth. 21% of our atmosphere, 89% of the Earth's water, 45.5% of Earth's crust, and two-thirds, of the human body. So all those are compounds. Only 21% of the atmosphere is pure oxygen. Actually, the most is nitrogen. But the idea is it's also found in foods, but it's always found as a compound. You generally find it as bonded with carbon, especially with foods or anything that's organic. You would find oxygen and carbon being one of the biggest things. But probably what we're mostly concerned about is rust. Rust is something that occurs between iron and oxygen. We'll get into that a little bit more. Okay? But some chemical properties of oxygen, you have it combines with elements and compounds. Rusting obviously occurs. You can make other oxides. The biggest thing is that methane reacts with other compounds. This is how our Bunsen burners will work. So that's a methane compound that's interacting with oxygen. Okay, again, not overly important. Hydrogen in the universe is 95% of all atoms are hydrogen. Okay, so and that's basically hydrogen, like we talked about with acids and bases in the last lecture. Hydrogen is just simply a proton. So when you start talking about the exchange of protons, that happens to be just hydrogen. Okay, but it's so reactive that it's seldom found alone. You find it with a multitude of different metals, many different nonmetals, especially carbon and oxygen, especially oxygen when you form water. Okay, so you form these hydrocarbons. Okay, but there was an experiment back in the first turn of the century that you would be really caring about going from 1899 to 1900, that turn of the century. We had these airships, and those airships were held up by pure hydrogen. Okay, so at the time, smart, it's lighter than air, so we can control how high we wanted to go with this. Well, there was one particular event with the airship, the Hindenburg. I'm not sure if any of you are familiar with that, but hydrogen is extremely flammable. Okay, and the reason why it's extremely flammable is because it reacts with oxygen to create water vapor. Okay, so when you have and nitrogen in the air to do those types of things, so it's incredibly flammable. Okay, it'll pick up and it'll start burning. Okay, and it'll get so excited that it started to burn this Hindenburg, and it fell out of the sky. This airship did, and it is just catastrophic. I don't have a picture of it, but it was a catastrophic deal. So they don't use hydrogen anymore. They use two protons, a two-proton gas called helium as their way to do those airships now, and it's not flammable, it's not reactive, so that's probably the best way to go. Okay. This is one of the original concepts I need you to understand about oxidation reduction is the three ways that oxidation reduction can be thought about. Okay, first of all, oxidation can be seen as a gain of oxygen atoms, and a reduction of loss. A reduction is a loss of oxygen atoms. Okay, so that's how oxidation reduction. That's one of the relationships. Okay, a second relationship is oxidation is a loss of hydrogen atoms. So notice that's the reverse. Okay, you can either gain hydrogen atoms, and that's oxidation, or you can lose hydrogen atoms, and that's also oxidation. So they kind of work in the reverse. It's just kind of substituting one for the other. And then if a reduction is a gain of hydrogen atoms, again, the reverse of number one there, reduction is a loss of oxygen atoms, and number two, reduction is a gain of hydrogen atoms. So it's the reverse of each other. The one that is most fundamental, probably the one that we'll deal with kind of the most, is actually the gain or the loss of electrons. So oxidation is where you will lose electrons, and reduction is where you'll gain electrons. So oxidation is where you'll talk about something becoming more positive. Reduction is something becoming more negative. Okay, so oxidation more positive, reduction more negative. Okay, so here's a decent little graphic for you guys to be looking on here. I'm not certain if you want to, but you might as well. Oxidation and reduction graph here, these arrows talk about increasing. Okay, so oxygen increases towards oxidation, hydrogen increases towards reduction, and the amount of electron increases towards reduction as well. So this is kind of a nice graphic if you just need a snapshot in your mind as far as understanding that concept. This would be a really good idea to draw in your notes. You can pause the video, of course, whenever you want to, and draw that really quick. It's a really awesome way to look at oxidation and reduction. Okay. Here's another way to kind of remember the idea between oxidation and reduction. Okay. Leo, the lion, says grr. Leo, the lion, says grr. So Leo, loss of electrons is oxidation. So loss of electrons is oxidation. Loss of electrons is oxidation. Grr would be the gain of electrons is reduction. Gain of electrons is reduction. Okay, so that's the one that we'll kind of stick with the most. All right, so let's talk about these here really quickly. Okay, if I was going to be describing this, is this reactant oxidized or reduced? Let's talk about it. Okay, we're talking about this particular lead right here. Okay, is it oxidized or is it reduced? Okay, so in this case, this one, since it's obviously gained oxygen, gaining oxygen is oxidized. Okay, whoa, a little crazy. Okay, tin oxide here. Okay, this would be specifically tin 4 oxide. Okay, if you wanted to name it. This one has lost an oxygen there, so this one would be reduced. Okay, be reduced. This next one here, potassium chlorate. Okay, in this case, it loses all of its oxygen, so all you have is potassium chloride, another salt. Okay, this one, since it lost oxygen, would be reduced. Okay. Okay. C2H6O. Now it's C2H4O. Okay, so now we've lost hydrogen. Okay, if we've lost hydrogen, okay, let's go back. Okay, losing hydrogen is oxidation. Okay, we'll talk about it right there. Losing hydrogen is oxidation. So this is oxidized. Okay, C2H2, C2H6. So now we're gaining hydrogen. Plus sign there for that. Gaining hydrogen, this would be reduced. Okay, so that'd be a good way to talk about. Obviously, we're gaining hydrogen here. We're losing hydrogen here. I'll put a little minus sign there. Okay, we've lost hydrogen, that's oxidized. Okay? So this again is pertaining to Leo. Magnesium and sulfur come together and form magnesium sulfide. This is kind of how you would draw it out originally. And then if we came down here, we're talking specifically about the electrons. Now, you kind of remember with ionic compounds, if we were to draw this out, magnesium would send 2 electrons, it's in group 2, over to sulfur, which has, sorry, those aren't very bright or big for you, which already has 6 valence electrons. So these come over here, just like this. So again, if we go back to Leo the lion, and we go back to this graphic right here, losing electrons, that particular reactant is oxidized. Reducing would be the gain the electrons. Again, loss of electrons is oxidation, gain electrons is reduction. Okay, when we look at this, you're talking about, okay, sorry, this one is losing electrons, that is oxidized. Okay, this one is gaining electron, this one is reduced. Okay, so losing electrons is oxidized, gaining electrons is reduced. Okay, so that's basically all 3 ways that we've talked about it. Okay, some common oxidizing agents: oxidized coal and electric power, gas and automobiles, wood and campfires, and food we eat are all based on oxygen. So oxidizing would mean that they lose oxygen. Antiseptics like hydrogen peroxide, we saw that reaction in our little catalyst experiment where the oxygen was being released. In this case, if it's losing oxygen, these are being oxidized. So in this case, hydrogen peroxide, the reaction we saw was a common oxidizer. Okay. Then of course, disinfectants like chlorine would be a decent way to look at something that's oxidized. Okay. Some common reducing agents, anything that's a metal. Okay, and some antioxidants. Now, every once in a while, depending on how deep into nutrition you guys have gotten, we'll talk about certain foods that are great, have high antioxidants. Okay, which means they they attract oxygen. This is interesting for the most part, since they're reducing. Okay, so metals will attract oxygen, antioxidants will attract oxygen and whatnot. So it's those way to look at it. Okay. So now we'll move on to the other objectives here. Corrosion. Okay, obviously that happens a lot with metal that's outside that has not been treated in any way. Some of you might own cars like this right now. Okay, if you had to sell that right now, it probably wouldn't be worth $100, $200. Looking at that car, or might be looking at a Derby here. Okay, might send that thing to the Derby. It could be a winner. It should be a light car though. Okay. Anyway, but corrosion is talking about the process whereby metal deteriorates, which means it breaks down. Sorry, doing this with the mouse really stinks. Okay. Anyway, caused by atmospheric oxygen, a lot of times with water, so something that's left out in the rain and sits out there with oxygen, obviously you have a rusting effect going on. So in cases of iron, corrosion can cause this rusting problem that we're seeing here. Okay, but corrosion occurs in the presence of atmospheric oxygen. The metal, which we're talking about, is oxidized, meaning that the oxygen is added to that metal. Okay, and sometimes corrosion metals can cause the buildup of an insoluble, or what we also call it, unable to be dissolved in water, solid layer around the metal. Okay, so you're talking about a metal that would eventually become oxidized, and then it won't be dissolved in water. So that's kind of a neat deal, because we can use that in 2 different things. One is galvanization. For those construction workers here, if you've ever heard of a galvanized nail, that's this process. It's a process of corrosion. Okay, on the outside of the nail, we're trying to protect the strongest part, the iron. Okay, and what we're going to do is we're going to dip that iron into some zinc. Okay, if it's galvanized in zinc, it could be galvanized magnesium for all we care. But for the most part, it's galvanized. Okay, so what ends up happening is the zinc protects the iron core, because the zinc will oxidize. Okay, it will be oxidized by the oxygen, and it will protect the iron on the inside. Kind of a neat deal. All right. Now we talk about electroplating of metals. This is kind of a cool process for those of you that want to do something neat with your life. This is the process of using electricity to attract positive metals, okay, positively charged metals, and trying to put them onto other metals. Okay, so you have to make one metal negative or attract these positive ions. Okay, so this is how these processes work. Okay, so galvanization and electroplating. Okay, here's galvanization. This is kind of a decent diagram I found on the internet, but basically you take the iron and you're going to try to clean the surface, try to get as clean as you can because you want a good fixation of your zinc. Okay, so eventually you take it all the way through here, and that's all you do. I mean, there's no electricity involved, no nothing. All you do is just put it in molten zinc. Molten means melted. Okay, and then you let it just sit there and cool, and as it does, it tightens up, and it actually will react with oxygen, and the rest will be history because you're protecting the metal inside there. Okay, so here's some decent examples. A galvanized nail would look like this. This would be a pure nail. Okay, this is pure right here. So you would dip this into a zinc bath, let it cool, and now that nail is going to last for a really long time because it's not going to rust. Okay, this zinc on the outside will break, will not necessarily break down, but will react with oxygen on its surface, but it will protect the nail on the inside. Okay, we've all seen kind of pails like this. It's the same process. It's just galvanized. Okay, a lot of finishing screws are galvanized with certain, with brass or certain finishes. It's all a galvanizing process. That's all it is. Okay, so those are some kind of neat ways as far as the metals are concerned. I don't know if you ever had a warm enough area and some access to zinc, you could galvanize something if you really felt like it. Here's electroplating. Like I said, this would be kind of cool if you guys really want to set it up. You really could. If you just had a battery, the things I saw on the internet were fairly significantly sized batteries. You're talking about like lantern type batteries, okay? And then access to a metal, okay? And if you wanted to galvanize a spoon or something like that, just get some cords running down to it. And this silver naturally is going to give up electrons. It's a metal. That's usually what they do. They give up electrons. So their ions, like it's showing here, okay, become positive. Okay? So the way electricity works is we're going to send electrons through here, and this metal here becomes electrified, carries electrons very easily, okay? And it makes the entire thing negative. Okay, so this spoon here is negatively charged. Well, opposites attract, so positive loves to find negative. Okay, so these positives are going to attract here, and so it's just going to get on there as much as possible, and they can shine it up and whatnot. And you can do this with copper finishings and whatnot. The idea is that positive attracts the negative. So you got to make this metal negative, like we have here. Got to make this metal negative. All these positive ions. This picture does a good job talking about how copper will break down, obviously. But the positive ions go here and attract to the metal. So electroplating. So for those people that are going to get rings later on, we have a gold ring. It's not gold all the way through. Sometimes it's just gold plated. Okay? And so this is kind of the way it looked before. Okay? This is the way it looks after. Okay? This was, something that will cry out to you kids as far as, relevancy. If you ever had the ability to electroplate a PlayStation controller, that'd be something interesting. I'm sure the rich people in the world might have that. But again, this would have to be some sort of metal, or it had to become negatively charged in order to attract that metal to sit on it. Okay, so that's galvanization and electroplating. Okay, again, those are two types of corrosion that's being used in the world right now. So that's kind of an interesting deal. Okay, and then finally, combustion. Fire! Okay, there's the presence between a non-metallic material, generally carbon-based, and a molecular oxygen. Okay, so we're going to take non-metallic materials. So these are things like carbon and sulfur and whatnot, and we're going to put them in the presence of oxygen, give them a little bit of energy, and then they just burn. Okay, they reduce themselves. Okay, or break down. Oxygen gains electrons from the non-metallic material. So generally speaking, like we talked about with methane at the beginning of the lecture, Methane will give up electrons to oxygen. That's why water is formed. And then carbon will actually gain oxygen and then form carbon dioxide. Okay. Combustion is generally classified as an exothermic reaction. We talked about that at the beginning of the unit, so make sure you reviewed that term because of its release of energy. Products of combustion are mostly carbon dioxide and water. Something else you need to be aware of course, is the release of energy. Okay. The release of energy is very, very important, so make sure that you talk about that as a product. Okay, so energy is also a product. Okay. Okay. Good. So the last thing to talk about, combustion. Combustion occurs in your body. It's known as cellular respiration. Breaks down of sugar in the presence of oxygen, used to create another molecule known as ATP, which is what the cells use for their cellular work. So this is kind of a main term, adenosine triphosphate. And cellular respiration, we'll talk about that a little bit more next year, excuse me. But that's kind of the basic premise. So that's oxidation and reduction. Hopefully we didn't go too fast. Rewatch if you need to. Refer to your notes. Thanks.